reschedule myself this time, but I got a letter to mail Friday. I had to be at the VA at 8 o'clock in the morning. It's like I can't miss an appointment. It takes months to reschedule. I'm trying to work on getting some disability stuff going on for being in the military. Yeah, it pissed me off that they never called me actually. Hey, when's it convenient for you? They send me letters like, you have a phone this time. Yeah. Right. Yeah, you could always it's not clean. I don't know. What different things I have wrong with it.
Hey, David. How are you over there? I see.
How you doing? Yeah, I'm here by myself.
I noticed that. Yeah, I'm running a little bit behind this morning myself, but we're here, good to go, right? So they'll be in soon. Okay, we're going to be doing a little bit of reviewing today for the final exam, just talking about some concerns you all have and starting to think about that next week. Your all's final is on Tuesday. Everybody remember the time? 1:20 to 3:20, right? So we'll write that back up here. Let me switch over here to so y'all can see. Tuesday, that's December the, I don't even know now, 9th, thank you. 1:20 to 3:20. Just in your usual classroom spot, okay? Unless you're here and you decide you want to go to Kingsport, or you're in Kingsport and you decide you want to come here or something, that's okay too. But just so you're at one of these rooms from 1:20 to 3:20 on Tuesday, that's great, okay? Now, I posted a final exam review sheet for you all. I sent you an email, right? So it's on D2L, and I made a change in that yesterday because I saw a mistake on it. Did y'all see that mistake? It was pretty close to the beginning, at least the one I saw. Maybe there's more and I didn't see them, but let me go over to your D2L site, and under study guide, you've got one here for the final exam. Okay, so I went in and I made a change because the first email I sent you, it told you to omit certain problems. Oh, I didn't make the change on yours. I put it in, but I must not have saved it. Okay, so there is a change that needs to be made, okay? I'll post that after I get back. I had it into post, but I must not have clicked save or something like that. It's on number 4 if you haven't noticed already. Did y'all notice that? Yeah, good. Some of you did. So on number 4, the answer, change the answer or make yourself a note until I get it reposted here. The answer is 4/3, not 3/4. Okay, so on number 4, let's see, should be 4/3. Okay. Now, I also told you some of the problems not to do. Remember those? It was, well, we got to get that 4/3 off of here now. It just wants to hang around. I'm going to repost this, so if you haven't, like if you're planning to print it off or something and you haven't already, hold off and give me a chance to repost it after this class, okay? Because what I'm going to do is go ahead and take out those that I don't want you to do, because we didn't talk about number 57 or 58, so you don't need to do those. No 57 or 58 for sure. And maybe that was all. It seems like there was one with 54, no 54. So don't do 54, 57, or 58 if you've already got this one out. Just mark those out, 54, 57, 58. And otherwise, though, I'm going to repost as soon as I get back, and it won't have those on it. Now your numbers will be out of order because I just literally just took them out, okay, like cut them out but didn't retype. So that'll look a little strange, and I adjusted the answers too. So I'll repost so it has the correct answer for number 4 as soon as I get back. Now, another thing. I didn't get all the retake tests back. I had the graduate student helping out grading those, and I thought they'd be back in my box this morning. They're not there, so I apologize for that greatly. However, if you're here on campus and are going to be around after, I'll be in my office after 12:30 for a little bit. So if you want to come by then and pick up your retake test, feel free to. I do have the ones, if you took the 3rd one, which is not very many of you, I have those to return to you, so it's just like 2 of you in here. But if you took test 1 or test 2 the other day and want to come by my office either after lunchtime today or tomorrow morning, feel free to come by. And if I'm not there, I'm going to leave it in an envelope in the little box by my door, okay? My office is 308 Gilbreth. It's letter O, 308 Gilbreth. My name's beside the door. And in case you've forgotten, I'm Jamie McGill, okay? Just in case. All right, so I think we're all okay on that, but Kingsport will be on their way back. They're not there to hear me right now, but theirs will be on their way back, and I'll email theirs over to them. So I'll let them know that. But questions you have about what's going on for the final on Tuesday? Yes, John.
Other than the identities, will we be provided all the formulas?
The formulas I've given you before, I will give you again, okay? So that means I will give you, let's go back to here. I will provide a formula sheet and a blank unit circle, just to try to make it easier for questions involving that. On the formula sheet, you'll have the same formulas we've had before, had given to us before, the sum and difference formula. Trying to write it too close together there. Okay, the double and half angle formulas. The law of sines, law of cosines, and the area of the triangle. Okay, area of triangles. We had two formulas for that, Heron's formula and the 1/2 AB sine C. Okay, so both of those, yes.
Are we going to have area, sector, and arc length and all that stuff?
Those I won't, well, those, if I give you, I'll go ahead and give you the area of a sector and an arc length, because I normally just throw those in with the problem. Instead, they're not really on the formula sheet, but yeah, we can have those. I'm not sure if I'm giving you those yet or not, okay? It's likely I may put something in there. Okay, so this was area of, does that look like a triangle? I like that answer, sure. Area of sector, arc length. I can give you those, okay? You still have to know your basic identities. Like always, you know, the sine, if you're talking about sine and just using x, y, and r, you want to know your sine is y over r. Your cosine is x over r for your angles. All your trig function identities like that. You want to know your tangents, your y over x or sine over cosine, depending on which way you're looking at it, or opposite over adjacent. So hopefully at this point in the semester, I hope we've made some connection between these things, even though we started off with unit circle. You know, we talked about x, y, and r stuff. We've talked about the identities themselves. We've talked about right triangle trigonometry, but hopefully we've made some relationships between those as we've come through the semester. Other questions there? Final is comprehensive, so it'll cover a little bit from each area that we've worked with. And everything we've worked with has been included either on the test or the study guide here as well. So this is a study guide, so it's to guide your study, just to give you some extra things to work on to prepare. Doesn't necessarily mean the problems will be exactly like what's on the study guide, okay, but they will be similar problems to what we've worked with in the past, okay, on tests at least, or study guide. Go ahead, Amy.
Will you show us how to go from the law of cosines to the cosine of like A equals A squared plus whatever it is?
Yeah, and I had that on the formula sheet though, didn't I? It was on there, yeah. On the one that I gave you with the test and the retest on test 3, but we can do that. So law of cosines said this, c squared equals a squared plus b squared minus 2ab cosine angle c. Now, first thing about that law, that's how it was written out on your formula sheet, and some of you may have forgotten how to adjust that if you were working for working to find a different value. In other words, you know, we could say a squared equals b squared plus c squared minus 2bc cosine angle a. We can adjust it for whichever letter we're looking for, right? Is everybody aware of that? And you know how to swap those in and out? Okay, because you want to be able to do that. Now, working, let's go back down here with this one, okay, because that's the one I'm going to work on, because that's the one that was I set out for you. That's the one that was initially given. If we're solving for angle C, algebraically what we're doing, first off, you can solve to begin with, and I think that's how I had it on the formula sheet, but you can just plug into this formula also if you want to. And what we're going to end up doing is we're going to have to subtract the a squared and b squared. So we've got c squared minus a squared minus b squared equals negative 2ab cosine of angle C, because we're trying to get that angle C by itself, the angle. Okay, we just want the angle. So now we'd have to divide out the negative 2ab because those things are being multiplied by the cosine of C. So we're dividing out negative 2ab equals cosine C. Okay. Over here, the way they normally change that around a little bit, they take that negative off the bottom part and actually place it up in the numerator instead. So what they're doing when you see this formula written out is they're multiplying both parts of the formula by -1, both the numerator and denominator, and so that you get negative c squared plus a squared plus b squared over 2ab. But then they change that around and say, well, it would look better if I said a squared plus b squared minus c squared, and maybe I'd remember it better if it was in alphabetical order. Okay, and over 2ab equals the cosine of angle C, making angle C be the inverse cosine of those values. Okay, whoops, it was a minus c squared. Okay, so that's what I think I had on the formula sheet the other day. Is that on there? Does anybody have their sheet? Maybe, yeah, okay. But again, we can adjust that one. So say we're looking for angle A. Angle A then would be inverse cosine of what?
B squared plus C squared minus A squared over 2 times B.
Right, so the two times whatever, it's going to use the two values that are not connected with the angle we're looking for. We're looking for angle A, so we're going to use times BC. Up on the top, we add together the two that are not associated, the squares of those, and subtract the one that is associated. Okay, so angle B is inverse cosine of what? A squared plus C squared minus B squared over 2AC, right? So you can adjust that depending on what you're looking for if you don't have your angles called the same as angle C for everything. Another thing, even though you can do the law of cosines first to find the values of your all your sides, or maybe all your maybe your side angle side. Some of you were using the law of cosines before you found your area of a triangle. You don't necessarily have to do that. Okay, you can go ahead and if you are given side angle side, you can use that 1/2 times AB sine of angle C formula for area. But if you're given all three sides, you can go ahead and use Heron's formula. You can do the law of cosines first if you're trying to use the alternate formula there. All right, what else? What's another question or concern coming up, Tom?
The first one is the inverse cotangent on the calculator.
Okay.
And then on paper as well. The second one was factoring out.
In an equation?
Yeah, factoring out an equation, and then the other way to do it, I forget how to do it.
Okay, I'm not sure, but let's get to that one here in a minute. Let's do inverse cotangent, okay? Inverse cotangent of a value. So let me go to, let's see if I have a copy of that here. Whatever it was that we looked at before. I don't think I have that one down right now. Well, the deal here is this. I don't know where that paper is, but anyway, the deal is this. If we have the inverse cotangent of 2, we're saying what angle has a cotangent of 2? We know the same angle would have a tangent of 1/2, right? The same angle that has a cotangent of 2 should have a tangent of 1/2 because those two values would be reciprocals of each other. Now, the thing we have to remember with the inverse functions is this. The inverse cotangent is defined from where to where? right, from 0 to pi. Okay, so the inverse cotangent is defined from 0 to pi. Actually not at the endpoints because it's undefined at those places, so let's put parentheses. The inverse tangent is defined where? Negative pi halves to pi halves. Okay, so whenever I look here and find an angle that has a cotangent of 2, first off, where's that angle going to be located? If I'm only interested here for inverse cotangent, I'm only interested from 0 to pi. Will it be located in the first or second quadrant if it has a cotangent of 2? First quadrant, because it's a positive value. If it's an angle that ends up in the second quadrant, it's going to have a negative cotangent, right? So we're never in the first quadrant. Now, if I'm trying to locate that value by using the inverse tangent of 1/2, where's the angle going to be that has a tangent of 1/2? Which quadrant? First or fourth? First, because it's a positive tangent. So we're okay on that to use this information. So on a calculator here, you would punch this in to get that value, and whatever it gives you is the answer. Now, whenever we're just asked about inverse functions like this, we answer in radians. Okay, normally we answer in radians on this type of problem. However, you all have also seen where we were solving the triangles and we answered in degrees because we were dealing with degrees of a triangle, or degrees of angles in the triangle. Okay. Now, the problem with inverse cotangent is when we have this. This is a new problem here. Okay. If it's the inverse cotangent of a negative value, and then if I use the inverse tangent of the reciprocal to get that, the inverse tangent of this reciprocal, that is going to give me an angle down here in the fourth quadrant. Because if I have a negative tangent, I'm going to be down in that fourth quadrant, right? If I'm only looking from negative pi halves to positive pi halves. Problem is, the inverse cotangent is not defined down there. So I need an angle that would have that same value for its cotangent up in the second quadrant. So this is where, whenever you get this worked out here, you get whatever you get here, angle in quadrant 4. It'll be a negative angle is what it'll be down there, a negative angle, but we can't have that if we're doing the inverse cotangent, if that was our problem. So we add pi to it to switch it up around to a corresponding angle. Okay, so that's what we get when we add pi, is what I just drew, but now I'm going to go back over that and say just this angle here, whatever it is, has the same cotangent value as the one that was down in the fourth quadrant. Okay, the way they're across from each other, they're corresponding there. So somebody do that one for us. I don't know what the answer is there, but the inverse tangent of negative 1/2, if you put, the reason we rewrite it that way is because we don't have inverse cotangent on our calculator. So be in radians for me a minute on there. Okay, put your calculator in radians, do the inverse tangent of negative 1/2. And what'd that give you?
Negative 0.46.
So negative 0.46 would be that angle right there in the fourth quadrant. But that can't be our answer for the problem we started with. So we add pi to it. When I add pi, what do I get? .68. Thank you. So that's this angle right here. That's that 2.68 radian angle there. That helps see the difference. So the problem comes when we have the inverse cotangent of a negative value. That's the only time we have to do this.
Yeah, that was the one that was kind of trouble with on the line math last quiz.
Yeah.
The cotangent of negative 9/8.
Inverse cotangent of negative 9/8. So you can do the inverse tangent of negative 8/9, but then you're going to have to add pi to it to bring it up into the second quadrant. Right. Okay. All right. So that brings up another thing. Don't forget the My Math Lab quizzes. Those do count, as a test average overall. So if you haven't done those, do those. That's kind of like make your own grade. You can do them as many times as you want. You can have a good grade, right? So, yeah, Brandon.
So what about the unit circle and the other?
Those average in with those quizzes, yeah. So the unit circle and the homework from Chapter 7 also go along in, even though they're not My Math Lab quizzes, that's where they're going in with, okay? So those two, along with you have 11 quizzes, just to clarify, you have 11 quizzes on My Math Lab. That's all you have to do for the grade part of the My Math Lab. Yes, there are pre-test, post-test homeworks on there, but you don't have to do those unless you want to. They are good for study purposes, but they were not in the required category. Go ahead.
Did you say you were going to drop one of the?
I said I would drop one of the things, either out of the 11 quizzes or the 2 homework type things. Out of those 13 things, I'll drop one. Okay? Makes sense there, but I'll drop one. All right, so we're approaching the end here of this stuff. What else do we need to talk about? Your other thing. What was your other thing again? Factoring. Okay. Like on the equations, right? Okay. So let me pull one from the textbook here for us. This one is number 74 off of page 461. It says 2 cosine squared theta minus 7 cosine theta minus 4 equals 0. Okay. We want to solve the equation. We're solving between 0 and 2 pi. That's where we're looking for our answers to be. Any solutions we can find from 0 to 2 pi. We're going to factor. So remember, just thinking about this kind of in reverse mode, I guess. The first terms have to multiply and give you the first term. So to get 2 cosine squared theta, we'll have 2 cosine theta times the cosine of theta. We don't have a lot of choices there because 2 is just 1 times 2 or 2 times 1. So it's just a matter of which way we put them in the parentheses. But this part here, when we multiply, gives us the first term there. Okay. Go over to the last term, the 4. Somehow we have to get a 4. We get a 4 from this term and this term being multiplied. Okay. The last term comes from the last terms in the parentheses being multiplied. So you have some choices. 2 times 2, 1 times 4, 4 times 1, right? Which way do you want to put it? Well, you got to figure it out in a way to where when you combine here with your outer and inner products, you're going to get that middle term of minus 7 cosine theta. Some people call it a guess and check method when you're working with this. I don't know. I see which one it's supposed to be. I don't know. Do you see which one it's going to be? Which one's it going to be? Okay, so she's told me to use 1 and 4, and she went ahead and put the signs in, but let's suppose I wait just a minute on the signs, okay? Sure enough, 1 times 4 gives me that 4. I do know that 1 has to be positive and 1 negative, so that when I multiply those, I get a negative 4, okay? Now, to get that middle term here, let's go to a different color there. When I get that term right there, that comes from here and here. The outer and inner products, the ones on the outermost part of the parentheses, the one on the insides, being multiplied. So the outer product here is 8 cosine theta. The inner product here is 1 cosine theta. Those have to combine to give me that minus 7 cosine theta, which tells me my 8 cosine theta has to be negative. So where did that come from? That came from the 2 cosine theta times the 4, and that's why Amy said to make that negative right there, okay? To get negative 8 cosine theta and positive 1 cosine theta. I've got so many colors going up here now, it's hard to read it. So That's more distracting than helpful. I thought it would be helpful, but maybe not. All right, so do we see the factoring there, though? Do you see where everything's coming from? Can you multiply that back out and check yourself? You might be able to do that, multiply your first terms. FOIL is just another name for the distributive property. So we're taking this one times the first one in over here. So 2 cosine theta times cosine theta, and then the 2 cosine theta times the minus 4. And then you come back and you pick up the 1 times each of those. Make sure everything in each set of parentheses gets multiplied by everything in the other set. Now to solve this, we're going to set each factor equal to 0. Okay. On the first one here, we're subtracting 1 from both sides, and then we're dividing by 2. And we're thinking, where is the cosine of an angle equal to -1/2? What angles have that happen? What are they? A little unit circle practice here. Where's the cosine equal to -1/2? No, not 3π4. 2π3, okay? 2π3, and where else? 5π3, right? 5π3, not 5π3, right? Whoa, hold on a minute, because the cosine's positive at 5π3. 4π3, right? So first, think about where's your cosine negative. Where's your cosine negative? Which quadrants? 2 and 3, right? So it's got to be angles out of quadrants 2 and 3. We know if the cosine's equal to 1/2, that is a pi over 3 type angle because it's 1/2 and then up to square root of 3 over 2, right? Following? Okay. So, but we're in the second and third quadrant, so it's got to be 2π3 and 4π3. So there's 2 answers for us. Now, what about this one over here? The cosine of theta equals 4. Where does the cosine equal 4? It's not going to happen. The cosine's not going to equal 4 because remember the range of that cosine was from -1 to +1, the values it could come out to be. So we're getting nothing from here. No values or no answers for that. We don't say that as an answer. We just say our answers are 2π3 and 4π3. Okay.
So our answers would just be 2π3 and 4π3?
Correct. Yeah. Just those 2 because we didn't generate any answers from the other part. Okay.
So for the other part, we just leave that blank.
Yeah. There's nothing we can do with cosine theta equals 4. Now, sometimes there'll be on the other factor answers that we get from there. Maybe it would have said the cosine of theta equals square root of 2 over 2, something like that. And then we would get those corresponding pi over 4 type angles for that. And they would become part of our solution for the whole thing. Okay. We're just looking for all possible solutions, and here we only had 2. Okay. Questions there? That one. All right, what's another thing that we need to bring back out? Yeah.
Establishing the identity.
Establishing the identity, everyone's favorite, right? Not really, but establishing the identity. Well, let me pull out something here from that. Just get the one off of here from the other day. Oh, it's not on that one. Which one's it? I pulled the wrong one. Which one was that on? The second one, right? Second one. I was going to pull that one out for those who did that here. 1 plus secant squared x sine squared x equals secant squared x. All right, establish the identity on this one. First off, when you're establishing an identity, always remember you're only working with one side of the equation, okay? You're not working with both sides. You're not solving anything. You're just trying to show that one side of the equation is equal to the other side, okay? So that's what we want to do here. Choose the most difficult side because that gives you more things to work with. So here we want the left side. On the left side, then remember, I'm trying to get to my goal. Always remember what your goal is. Think about things you can do. Usually there's only a few things you can do. Okay, you might be able to change things to sines and cosines. You might be able to multiply something. You might be able to divide something. What can I do here? 1 plus secant squared. Well, okay, but the secant squared is being multiplied by the sine squared. So that brings up another thing. We can look for some other sort of identity we can rewrite something as. Okay, 1 plus secant squared x is equal to tangent squared x. But this 1 plus secant squared, I cannot separate the secant squared from the sine squared x there because they're being multiplied. See what I mean? It's not 1 plus secant squared in parentheses times sine squared x. So what can I do? But maybe something with the Pythagorean identities. Okay, just the 1. Okay, because maybe I'm mishearing you, but my first impression was you wanted me to take that part. Okay, and that's what I can't do. I just want to make sure I'm hearing correctly then. Okay, so the 1, what would you like me to do with the 1? We're just trying stuff, okay? So anything's good. You want me to rewrite the 1 as sine squared plus cosine squared? Or what? What do y'all think? Rewrite secant squared x as 1 over cosine squared x. So just change it to the reciprocal identity that it is. So we still have 1 plus this times that, okay? And then that's 1 plus sine squared x over cosine squared x, right? Which is tangent squared x, which is, yeah, that's an established identity. So that's probably the quickest way to do this. Well, it's not the only way, but that's the quickest way, okay? We could have rewritten maybe sine squared x as 1 minus cosine squared x and then multiplied it by the secant squared x and seen what that gave us. There are some other ways to get to the other side. This is probably the most straightforward way right here. So we're looking for ways to rewrite some of the expressions. Let's do another one of those. I'm going to get one off the study guide here that I put on here. 38 or 39. Does anybody have a preference on 38 or 39 if you looked at the study guide? It's a party. We'll do both. Okay. All right, 38, we have tangent u times cosecant u minus sine u equals cosine u. Okay. What can I do first? I don't know. First here, I think I want to multiply because I see tangent u times stuff in parentheses. So I'm going to multiply first, okay? It's not the only thing I could have done first, but it works. So let's see here. So I'm distributing tangent u times each of these. All right, now what? What can I do? Remember my goal. I've got to get to a cosine u. So what might I want to do now? All right, so that's sine u over cosine u times, maybe I want to go ahead and change cosecant u also then. If I'm going to change to sines and cosines, let's change cosecant u to 1 over sine u minus sine u over cosine u times sine u. That's sine u over 1, by the way, if that helps. Okay. Over there. Now in the first multiplication part here, in that first product, sine u over cosine u times 1 over sine u, I can divide out or cancel out those sine u's. So I'm left with 1 over cosine u there, minus, over here there's nothing I can cancel, but I can say sine squared u over cosine u. Any questions so far? Well, they have a common denominator and we're subtracting, so just for an extra step, let me just put those together. And 1 minus sine squared u is equal to cosine squared u over cosine u. That's equal to cosine u, right? And that's what I wanted there. Because the cosine u in the denominator divides with one of the ones up in the numerator, giving us cosine u. We're looking for things we can do when we're establishing these identities. Any questions on that one?
What do we get cosine used by taking off one cosine on top, right?
Right. This is cosine u times cosine u is what cosine squared u means. This is cosine u down here. That's what's happening, right? We're left with 1. All right, so 39 also. Let's put it up here then. Sine x times tangent x cosine x minus cotangent x cosine x equals 1 minus 2 cosine squared x. Okay. Left side looks more complicated. We'll work with it. Again, this one's very similar to the one we just did actually, but sine x, tangent x, cosine x, when I multiply the sine x times all that, and then sine x times all this, so minus sine x, cotangent x, cosine x. Change to sines and cosines, probably because this over here just has cosine in it, so probably want to do that. I've got sine x times sine x over cosine x times cosine x minus sine x times cotangent cosine x over sine x. So now what? What can I do to simplify here? Those cancel. Cosine x is canceled there. Sine x is canceled here. That's sine squared x minus cosine squared x. But I want 1 minus 2 cosine squared x. I don't want any sine x's in what I get. I don't want to have sine x's. What can I do? Okay, sine squared x is equal to 1 minus cosine squared x. So that's equal to all that. And then we have minus cosine squared x. And that would be 1 minus 2 cosine squared x. Then when I put those cosine squared x's together. Okay, minus cosine squared x minus cosine squared x is minus 2 cosine squared x. So just look for things that we can do with that. Other questions on the identities? Let me skip down to number 53 just a minute, just in case there was a question on 53. Let me go down there. And this is totally different. This is chapter 14. Limit as x approaches 0 of x cubed plus 12x squared minus 5x over 5x. And we said, you know, algebraically we can just plug the value in. Very often that can happen. But when I do that here, what do I get? 0 over 0. 0 over 0 is, it has no meaning. Okay? 0 over 0 has no meaning. When you have any other number over 0, we say it's undefined, but 0 divided by 0 is a meaningless expression. And what we need to do here, even if we had 1 over 0, which is undefined, when we're doing a limit, we need to explore that a little further. And so we mentioned that we might need to factor in order to simplify an expression. So let's see what happens when we factor this. Up on top, I have a common factor of x. If I factor out an x, I'm left with x squared plus 12x minus 5, and it's over 5x. I think there's one on My Math Lab that does this, where you have to factor. It might be that you have to factor into the FOIL type method, but you're going to have to factor and cancel something. It's on quiz 11 there. All right, so we'll have to cancel those x's. And now we try to plug the 0 in. We got rid of the part that was making it not work, didn't we? It doesn't work if we get 0 in the denominator. So when we get 0 in the denominator and we're working with a limit, which we didn't go into great detail with that, but when we're working with the limit, we get 0 in the denominator. Then we try to factor and do some canceling to simplify the expression, and then substitute the value in. There's other techniques also, but for us now, this is all we're going to look at since it's the last day of class. Okay, so what does this give me then? Yeah, -1, because I've got -5 over 5, which is -1. Okay. But that's what we would do with that. Now, I think some of you had another question about something else before I threw that one in. So what was another question there about the topic or question off the study guide, old test, whatever?
Could you do an entire one? It's like has a cable.
Mm-hmm. I've got one on here actually too on the study guide here. It's our like favorite problem of all time. Huh? A radio transmission tower is 220 feet tall. How long should a guy wire be? If it is to be attached 6 feet from the top, so we attach a wire. Here's the ground. When we have a tower in the ground, by the way, we're going to assume that it's perpendicular to the ground. I guess that's a little bit of an assumption, but that's what we're assuming on these problems. Okay. So we have a 220-foot tower. It's attached, the wire is attached 6 feet from the top. So that means just down to where it's attached was 6 feet, which means the side of my triangle that I formed here is what?
214?
Yeah, 214 feet right there. We want to know how long the wire should be if it's making an angle of 30 degrees with the ground. You know, this is the ground down here. Okay, that's the tower. Okay. So if it's making an angle of 30 degrees with the ground, how long is the wire? I'll call the wire X there. Okay. I can use right triangle trigonometry on this. Some of you like to use the law of sines. That's okay also. Right triangle trigonometry is probably what I would choose, and I would say the sine of the 30-degree angle. Sine is equal to the opposite side over the hypotenuse. So that's what I have here is the opposite side is 214 over the hypotenuse x. So I get, I'll multiply both sides by x and get x sine 30 degrees is equal to 214, and divide by the sine of 30 degrees. Well, you know the sine of 30 degrees, right? What's the sine of 30 degrees? Is it? 1/2. So 214 divided by 1/2 is the same as times 2. That's 428 feet. Okay. That one. You could use law of sines. If you did use law of sines, then you would set it up like this. Sine of 30 degrees over 214 equals the sine of 90 degrees over x. That also works. So you've got x sine 30 degrees equals 214 sine 90 degrees. X is going to equal 214 sine 90 degrees divided by sine of 30 degrees. Even though we know these values on this one, we know the sine of 90 degrees and the sine of 30 degrees, whatever those angles are there that we are using with the trig functions, don't go to the calculator real early. A lot of you are just dying to pick up that calculator and punch buttons in. Okay, wait till the end. So even if those were things we didn't know, wait till this point here before you type it in, because otherwise it's generating a little bit of round-off error there. And it makes it deviate a little bit more than it should, because you're rounding when you do the sine of each of the angles, and then you're rounding when you do the division. It's too much rounding going on. It'll actually save you time if you wait till the end of the problem to punch stuff in the calculator. Go ahead. I did, okay. So on this one, we don't even need to punch stuff in, though, because we know what these values are. So on this one, we just say x equals 214 times, what's the sine of 90? 1. Sine of 30 degrees, we already said was 1/2. And so 214 again divided by 1/2 is going to give us our 428. Okay, for that one. Let's see, what else there? What else? On which one? 46, okay. All right, so back to golf. Let's do some golf here. A famous golfer tees off on a straight 390-yard par 4. Okay, we don't really care that it's par 4. That part doesn't matter to us. But somewhere you've got your golfer, okay? Now, remember, our drawings are not 3D. It'd be nice if they were, but they're not. So here's going to be the golfer with the tee, okay, where he hits the golf ball off of it. And he's trying to hit it to some hole that's out here on the green. The hole's on the green, right? Who plays golf in here? Okay, so we're good so far, right? And it's a straight 390 yards to get from the tee to the hole. But when he tees off, okay, that's the path he should have taken, the straight 390 yards. But when he teed off, he sliced his drive to the right. That means he hit the ball to the right, okay? So he was here, but the ball went here somewhere. I don't know how far out it went. What does it tell us? The drive goes 290 yards from the tee. So that went 290 yards, and that's where the ball landed, somewhere out there. Okay. Using a 7-iron on his second shot, so he just switches what club he uses, right? He hits the ball 180 yards, and it lands inches from the hole. For our purposes, it's right by the hole, okay? It's there. We might as well say it's there. So he hits it 180 yards to get it from there to there. Even though this might look like it could be a right triangle, we don't want to assume that. It's just because of my diagram. Okay. How many degrees to the right of the line from the tee to the hole? Okay, so we're looking for, and it said, did he slice his drive? So when he meant to hit the ball straight, but it went to the right anyway, we want to know at what angle was that it went to the right. How many degrees to the nearest degree to the right of the line from the tee to the hole? All right, here's the line from the tee to the hole. To the right of that line, and to where he sliced the drive. Okay, that's what we're looking for, this angle right here. The T angle there. Right, the one I've got T written at the vertex. All right, so if we're wanting to know that, then if you're going to label this according to your A, B, C, like to go with your formula, and we want it to actually be angle C we're looking for, I guess, based on their formula. I'll call that C, meaning this is C here. And A and B don't really matter. However, this looks bad if I put A there. Never mind, maybe it doesn't. Okay, so And we'll put B here. We'll leave it there anyway. Okay, so here's what we've got. And we've got angle C is equal to, on that formula we worked out a while ago, inverse cosine of, remember it was, I'll put the formula up here, a squared plus b squared minus c squared over 2ab. So angle C here is going to be the inverse cosine of 290 squared plus 390 squared minus 180 squared over 2 times 290 times 390. And again, I would just wait till now, and hopefully you can put all that in your calculator without having to stop and write each part down. But be careful, because everything on top has to be added together before you divide by that 2 times 290 times 390. So if you put that in your calculator, now your calculator's in degrees, by the way, because we're in this triangle. So you want to keep straight what mode you need your calculator in, you know, on the final exam. So be very careful about that, because so far it's been pretty much, you know, on test 1 you had to switch a little bit. No, you didn't, because you didn't use a calculator on test 1, right? Forget that. You didn't have to switch. You had to maybe think about it differently. Test 2 and 3, though, test 2 we were in radians. Test 3 we were in degrees. As far as calculators were concerned, on the final it's all on there, so you have to make sure you know which one you're in for what you're doing. Here we're doing triangles. We want it in degrees. What do you get for angle C here? What was it?
25.7.
Okay, and they said to the nearest degree, so 26 degrees. That's what we would go with there then. Does that help on drawing that out, though, a little bit, on the going from the words to the drawing? And again, this is a guide, so look back at some of those types of problems. And I know you have some word problems on My Math Lab that maybe you can draw out. Some of them are drawn out for you. What else there? Anything else on this one here? Let me raise it back up just a little. Anything else on that one? All right, what other concerns do we have? Yes?
35 or 36.
Okay. Was that a both or either or? Okay. Well, let's go to 36 then, because it's a little more involved, okay? 7 inverse cosine of x minus pi equals 5 inverse cosine x. And again, we're solving an equation. We want an exact solution. Anytime it says exact, what does that mean? What's that?
Radians?
Not necessarily radians. It may be, but it normally is, but not necessarily. But what does exact mean? Keep it in its fraction form. If it has square root of 21 over 5, we leave it square root of 21 over 5. We don't use a decimal. Okay, decimals are not exact because they're approximations. We're usually having to round them off. So basically, when you see exact, that's probably going to indicate to you, I shouldn't be using my calculator for this, right? I mean, that's kind of a paraphrase, I guess, of exact. All right, so here we're wanting to solve the equation. So this is another type of equation. We do not have to factor on this one, but we do need to get x by itself. So what are we going to do to get x by itself? How will we start this one?
Add pi.
Okay, we could add pi. We can, but we need to try to get these two things together. Or are you going to do that over on the other side then? Are you going to do that after you add pi?
I was just saying like something for each choose.
Okay, and we could add pi. It adds an extra step, but it's okay to do that. If you add pi, let's do it then. Maybe several of you were thinking that way to do that. And that's okay. Whatever you do, wherever you start, whatever you think of first, just make sure you do it to both sides, okay? And then reevaluate and look at it and say, what am I going to do now?
plus 7 inverse cosine.
Okay, so am I going to work, if I added pi and I've got it like this now, do I want to move the 7 inverse cosine or the 5 inverse cosine? I would want to move the 5 inverse cosine and get it over with the 7 inverse cosine. I do need to get them together, but if I get them together on the same side with pi, then I'm going to have to move something back again because I'm trying to get x by itself, right? And I don't want that pi over there with it. So let's subtract 5 inverse cosine x. That's going to give me 2 inverse cosine x equals pi. 2 inverse cosine x equals pi. What now? Divide by 2. Good. So that's inverse cosine x equals pi halves. Now what? Take the cosine of both sides. So that's going to give me, remember the inverse of the function or the function of the inverse just brings out the x there. X equals the cosine of pi halves, which is what? 0. Okay, so that's how we would work with those. And 35, all you had to do on that one starting out was divide by 6. It didn't have the part about moving something through addition or subtraction. So hopefully it's not quite as bad on that one there. Other questions here on this one? You could have saved one step here by starting out with subtracting 7 inverse cosine x from both sides. Okay, and that would have gone ahead and gotten your inverse cosine x terms together with the pi on the other side. It actually would have been negative pi, but it would have worked as well. What else? What other concerns and questions? Let's do 22. Okay, I'm going to choose 22 because of some things I saw on whichever test that was on. Okay. It goes back a ways. Chapter 6. 4-3. Find cosine of theta. A point on the terminal side of an angle theta is given. Find the exact value of the indicated trig function of theta. The reason I chose this one was because still there's a few people who want to say that the x is the cosine and the y is the sine. That's only true if you're in a unit circle, and if there's no indication you're in a unit circle, then you cannot assume that. In this case here, to find the cosine of theta, what they're telling us is that this is a point on the terminal side of the angle. So 4-3, you don't really have to draw it to see what's going on, but I'm going to draw it for you anyway. Okay, so 4-3 is right there, and it's a point on the terminal side of the angle. In other words, we have some circle going through this. That's a pretty bad circle. Pretend with me. Okay, you've pretended with me all semester now. All right, so to get the cosine here, we know the cosine is equal to whatever what? Yeah, x over r. Theta will be our central angle. So even now, you know, once you know theta is always your central angle there that we work with, you could still use your adjacent over hypotenuse or something like that if you wanted to. But x and r, we're already given x and y. How do I get r? How do I know what the radius is? Yeah, I've got to do this first. So whether I draw the picture or not, I've got to do this. I've got to know which quadrant I'm located in, even though r always comes out positive, but that may help on finding my trig function value, whichever one it might be. This was in the first quadrant because the point 4-3 was in the first quadrant. So I have 4 squared plus 3 squared equals r squared. This is a common Pythagorean triple, though. I should have asked you beforehand. That's 4. That's 3. R must be 5, right? But this is what we would do, you know, this procedure, if it, whether it is or is not a common Pythagorean triple. Take the square root to get r. So r is 5. And now we know the cosine of the angle is what? 4/5 there. Okay. Cosine of the angle is 4/5. You could find any of the trig functions now for that angle. But always remember, if you're just given the coordinates, find what that R value is. Okay. What else there? Trying to remember here, what else? What about 37? Let's go over to that one. I'm just picking for you right now. Cosecant of the inverse tangent of -2/7. This is another find the exact value. And I'm going back to some of these older ones a little bit just because they have been a little further back in our mind from other things. But this is telling us we want to know the cosecant of the angle that has a tangent of -2/7, because this part in here is asking us what angle has a tangent of -2/7. Nothing from our unit circle fits that. Nothing from the unit circle, so we're going to have to draw an angle that has a tangent of -2/7. Now, where would that angle be located if it has a tangent of -2/7? Down in the fourth quadrant, right? Because the inverse tangent was defined from -π/2 up to +π/2, right? So we want to keep those things in mind. So this angle theta, we're going to make it have a tangent of -2/7. The tangent of theta is -2/7, meaning that y is -2 and x is going to be 7 because tangent's y over x. So y is -2, x is 7. And what I really ultimately want then is the cosecant of that angle that has that tangent. So the cosecant, we know the cosecant's the reciprocal of the sine. We know the sine is y over r, so the cosecant must be r over y, right? Okay, so r over y, that's something over -2. What's r though here? Well, we'll have to figure it out again. So 7 squared plus -2 squared is r squared. It looks like it's the square root of 53. So that's what we were looking for there, the square root of 53 over -2. Or negative square root of 53 over 2. Right? So going back, you want to remember your unit circle. By all means, remember the unit circle. Okay, that's been important all semester long. You want to keep that up here in your head and know the identities that are associated with the unit circle as well. You know your Pythagorean identities, reciprocal identities, quotient identities. Know how your trig functions work with x, y, and r. Know how to convert from degrees to radians, radians to degrees. Know the difference in working with radians and degrees. Okay. We want to know how to use those formulas that we talked about would be on the formula sheet. Know how to use those formulas from chapter 7 and 8. Know how to work with the limits. Maybe establish an identity like we looked at today. Go ahead.
How many questions will be on the exam?
How many questions on the exam? Well, it's still kind of in creation right now, so I can't answer for certain, but it will not be, it won't be that much longer than like normally your tests have like 10 questions, maybe with some multiple parts. It might have at most, 12, something like that, but maybe multiple parts there on some of them. It's not completely finished yet, so I just kind of have to gauge my timing on it, okay? It won't be overkill or anything like that, but it will cover every thing that we've been over. The final exam doesn't count any more than any other test, okay? Still important. I'm not minimizing importance there, but it's not like it's weighted more heavily either, okay? What other questions about the final? You need to bring something to write with and bring a calculator that you know how to use and that's not a cell phone calculator, okay, for the final exam. What other questions? Cheyenne, you have any questions over there in Kingsport? No, we're good?
No, I don't have any.
Okay, all right. If anybody does come up with questions, definitely send me an email. I'll answer you, or if you want to set up a time to come meet with me, we can do that too. Okay, remember my office hours will be different next week because my class schedule's different, like your final exam schedule's different.
What time did you say we could go pick up the retake?
Yeah, if so on your retake, 2 of you, if you took test 3, get it back for me before you leave today. The other test didn't get finished grading quite yet, so I will be emailing yours to you, Cheyenne. I'll also send it, but I'm going to go ahead and email it to you, so check your email later so that you'll have it back, your retake test. And over here, if you can come by my office either after 12:30 today or in the morning. I know you all don't have classes tomorrow, but if you want to come by my office in the morning, I'll be there then and can give it to you as well, okay? Any questions about that? All right, just study. Let me know if you have questions in the meantime, and I'll see you all back on Tuesday.
one time. No.